think we'll get started then. So last session here on BigBird, I'm excited to get to some new topics, but this has been pretty cool. Got a couple things to share with you guys this week. So last week, was it Nolan McCormick? Was that his name? Someone gave us a great idea on a way to modify our example. I'll make sure to credit him in the description or something. But his suggestion was basically to take from the 20 Newsgroups data set, just take the samples that are longer than 512 tokens and compare BERT to BigBird on those. So I did that. And then I took a look at an example notebook that actually came out of Huggingface that demonstrates BigBird on a question answering benchmark. So let's take a look at what I've got here. All right. So I filtered down just the test set. I still trained BigBird and BERT on the full training set, but I filtered the test set down to just 680 samples that are longer than 512 tokens. One little interesting note is that BERT uses the original BERT tokenizer. BigBird was built off of Roberta and uses the SentencePiece tokenizer. So they have different tokenizers, and I found that they actually have they produce a different number of tokens per input text. So it was actually pretty important that I use the BigBird tokenizer to filter the test set in both cases. Otherwise, they'd be misaligned a bit. So here's kind of the distribution of comment lengths in that data set that are above 512. So a lot of them are under this 1,000 mark, but there are, there's a tail here. Plus a lot that I guess are just enormous. Let's see. So I tried comparing. I used BigBird with a maximum length of 1,024, mainly for memory concerns, and then BERT with max length of 512. So that means BigBird, looking at this distribution chart, BigBird still isn't capturing the full length of all of the test samples. And I guess what I did here actually is I for this distribution plot, I truncated everything to 4,096. So I think this bar is large here because there's actually a number of samples that are way off to the right. I think the longest one is actually like 50,000 tokens. All right, so for BigBird, for my first trial, I used the sparse attention. I used full attention a little later down here, but basically BERT still outperformed BigBird, unfortunately. It was, again, this is like BERT's just truncating to 512. BigBird is truncating to 1,024, but BERT still had a higher F1 score. And I did look at, how many of the samples that either one or both got wrong, like how many times was BERT correct and BigBird wrong. There's 41 of those, and then there's 32 where BigBird was correct, but BERT was wrong. And then there's 91 where they were both wrong. So BERT did better. I'm not sure we're gonna be able to demonstrate BigBird, outperforming BERT on this data set. It did occur to me after that I used sparse attention, which sparse attention does presumably cost you some accuracy. So if we're only doing 1,024 tokens, should probably try full attention. So I did that. It did cause some problems. I couldn't use a batch size of 4 anymore. I ran out of memory. So I switched to a batch size of 2, but then the model during training, it failed to learn. Its test scores were terrible. So I think the learning rate needed to be adjusted in order to work with this batch size. I did read something recently that kind of explained that like if you cut your batch size down, then that means you're going to be taking a lot more steps over the course of your epochs because you're breaking your training set into smaller chunks. So if you increase the number of steps, then it makes sense to reduce the learning rate so that each step has a smaller change. So I cut the learning rate roughly in proportion to the change of batch size. So kind of cut it in half roughly, and then it trained successfully. But it got worse. So full attention did not help. And yeah, just out of like curiosity, it seemed like maybe an interesting opportunity to look at training times. So I was using a Tesla P100 for all my experiments. The sparse version of BigBird took 39 minutes per epoch with the max length of 1024, whereas truncating BERT with a max length of 512, is roughly 11 minutes per epoch. So even with sparse attention enabled, BigBird, the epoch is almost 4 times as long for BigBird. But if it were linear, it should only be 2, right? Because the length of the sequence is twice what it was for BERT, not 4 times. So we're still seeing like a quadratic growth or quadratic difference, I'd say, in the training times. But I think that may be because we're at a lower maximum length. And the authors did say like, don't use sparse attention for 1024 tokens or less. So this may be what they're referring to, is that you don't actually get that linear relationship with length. It did require less memory though, as evidenced by the fact that when I switched to full attention using the same parameters, I ran out of memory. But yeah, training time was still quadratic. And then somewhat strangely, when I tried full attention, it was actually faster. It's 27 minutes per epoch instead of 40. So there was, however, and the batch size was lower, which if anything I would think would make it, slower. But again, I'm wondering if it's like the sparse attention does add, it adds some complexity to the attention calculation. So there's like less calculations to do, but it's not just a straightforward matrix multiplication. There's more steps involved. So maybe again, if your max length is too short, then the sparse attention actually does more harm than good there. Yeah, let's see. I think that's it. So I think I am done messing with that data set. I think we've failed enough times here. So that was a good suggestion though. I like that. I think that was a much better way, I think, to look at this data set. Even though it didn't really pan out, at least we tried. And I think those results are hopefully interesting for everyone. Okay, yeah, and then I just have a few notes on this notebook. I didn't go through it in detail and polish it up or anything like that, but did kind of read through it and gather my thoughts on what's there. So it is the text in the notebook is well written, so really appreciate that. The code can be kind of dense in places, but it does have some comments, so that's nice too. It uses a model, a BigBird model that's already been fine-tuned by Google on the TriviaQA benchmark. So there's no fine-tuning required in this notebook. It's just doing evaluation. And then it doesn't handle some of the reference texts or the context in QA terminology are longer than 4,096 tokens, so they don't still don't fit in BigBird even with that much larger limit. So the authors of BigBird, have some code, some techniques for addressing that, for presumably, breaking the document into some kind of chunks and combining the results in some way. The notebook doesn't include any of that code. It just gets around that issue by filtering down the test set to just the ones that are 4,096 tokens or less. And then, it also doesn't really show, it doesn't demonstrate improved performance. And I think that's just because they filter down the test set, so it's not the full benchmark. But there's nothing there. I think they get a decent score, but it's not nearly the score reported by the authors of BigBird. So what I did appreciate though, that it implements is that if you're trying to implement QA evaluation where you want to apply a fine-tuned model to question answering, then the simplest thing you can do, and I've got a notebook that does this, is you can feed in a question and the reference text, have the model predict the most likely span within that reference text, and then print that out to the user so you can see it, right? So that's the simplest thing to do. But if you actually want to score it against this entire test set with ground truth, then that's more complicated. And there's tricks that you want to employ to make sure that you're not kind of unduly penalizing your model for getting mostly the right answer, but not exactly. So it does include the code for doing that. It does actually run the model against a large set of test samples and scores it. So that's pretty cool. And it does. It also, I know there's an example script in the Huggingface transformers library that implements the squad benchmark for BERT. And I've gone through that, but the code is monstrous. It's so brutal. So it was really nice to see here that he pulled out some of these details around scoring. He kind of pulled out into their own functions and added a little explanation of what they're doing. So I think that's pretty valuable. So I think it's definitely worth checking out for question answering in general. Still not the full implementation, though. He does point to Google's code for doing the handling the longer than 4K tokens samples. So depending on what that code looks like, maybe you could add in those details, pull those in. Okay. I think that's all I've got to say about that notebook. Let's see. Right. Yeah. And it was written by Patrick von Platten, works for Huggingface. So some next steps for me. I'm planning to kind of take all the research that we did here and create a PowerPoint tutorial explaining the BigBird architecture. So yeah, kind of just polishing what we covered in the first few episodes, I think, of this series. So that'll be in the BERT collection, and then I'll clean up my examples that I did or experiments that I did with the 20 Newsgroups data set, and I'll include those as well. So yeah, for the coming weeks for this discussion group, I think our next two topics, Nick has been working on question answering systems, and not just the not just the like squad style where you're trying to identify a passage in the reference text, but also like generative models, more like a chatbot. So he's going to go through kind of a series of progressively more sophisticated systems for that. So I think that's going to be pretty fun. And then we've had a number of people ask about incorporating categorical information into BERT. So yeah, or what's another word for that? Is it canonical? Yeah. So when you've got like a property with, that could have a few different values, and you want to incorporate that into you want to add that with your text and then do some classification or whatever your end task is. So yeah, anyway, so some people have asked about that, and I'm really interested in it too. So I'll be looking at that, and I think we're either going to alternate between Nick and I leading the discussion group, or we'll see. Still got to figure that aspect out. But those are the next two things coming. All right. So with that, I think that's everything I've got. So I'm going to switch over to the Q&A section, which I will drop those. It's the link for the Q&A doc, and there's the link for the research journal. Cool. So does anyone have any more questions about BigBird that we could try and answer here? Probably should have prompted you guys earlier to type them in the chat if you had them, but.
I have a question. Earlier you said that one of the reasons that the performance could be, not the performance, the timing per epoch could be quadratic is that we are using 1024 embedding size, right? Instead of that, if you use 2048 embedding size, then you could see a quadratic, a linear growth in the time rather than quadratic. So how are you going to incorporate that, given the fact that with 1024 only you are getting only two inputs per batch? If you increase it to 2048, how are you going to what will be your batch size?
Right. Yeah. I guess what we'd have to do there.
And without increasing the capacity of like GPU.
Right.
Seems very difficult for me.
So let me see if I've got that. Sorry. Yeah. So if you wanted to test out sequence length of 2048 to compare the training speed 2024. How would you do that given the memory limitations? Yeah. So you could, I guess one option would be like you could use multiple GPUs, though this adds some overhead as well.
Yeah.
You could use, what do they call it? So I learned a couple weeks ago that there's this, NVIDIA has these like A6400 that have, I want to say it was like 48 gigabytes of RAM. Lambda has those. I remember I wanted to, should go see, let's go see if we can like grab one of those. Where is the cloud? There we go. GPU cloud. Yes. A6000, okay. Can I have one? Hey, all right. They gave me one. That's pretty cool. Yeah, maybe we could try running on there real quick, see what happens. See if it fits. Yeah, otherwise, so it's A6000. Yeah, so if you cut the batch size, right, that would increase the, well, I guess it would be to 2, right? I suppose you could, maybe it would be fair, like, maybe it would be fair to measure that and divide the time in half. Say like, well, presumably if it were a batch size of 4, this could be as much as twice as fast. So if you cut the batch size to 2 and use length 2048, and the time only increases by roughly 4x, then that's a good sign that you're getting sub-quadratic. Was that growth? I don't know. Yeah.
Yeah, that makes sense.
Yeah, let's see. I don't think I'll launch into this right now, but maybe right after the meeting I can play with this and see if it delivers on that 48 gigabytes. Just be curious too to just see like NVIDIA 6000 48 gigabytes. Quadro, interesting. That's their that's their line for rendering.
Yeah. Generally, that is now.
$48 gigabytes of GPU memory. Cool. I've always wondered why they haven't done that sooner. Like what's the limit? Like if us machine learning engineers are all complaining about memory limitations, then like why not throw some more RAM on there? There's got to have a good reason for that. But it's cool to see that they've upped it, at least in that chip. What's the is there like a Tesla GPU that's Ampere based? NVIDIA Ampere Tesla GPU. A100. Okay. Oh, no, don't want the white paper, thanks. Just take the marketing brief. Tensor Core GPU. Unprecedented. Oh, cool. Yeah. All right. 40 gigabyte and 80 gigabyte memory versions. Nice. So maybe we'll have access to those eventually here from, I don't know what, Amazon, maybe Colab. Right now, the best I get on Colab is I've been getting P100s lately, but I've gotten V100s, which I think is the previous architecture behind Ampere. Architecture timeline. Tesla, Fermi, Kepler, Maxwell, Volta. Yeah, where's Pascal? Somewhere in there. Yeah, Maxwell, Pascal, Volta, Ampere. Cool. Sorry, so we also learned Tesla A100s have their 40 gigabyte access to one. Yeah. Yeah, sorry, I'm looking over at the chat. So that's a good insight, Diogo. I've been curious about that. Add your comment in here. I like that. Like, normal people use the RTX GPUs. I'm gonna kill my. Speaking of GPUs, let's stop paying for erase data on instance. I like that. It's cute. Yes, delete all of my work. Thank you. Right. So, yeah, the like Tesla GPUs include ECC memory. The right way to say it's like electronic error correction. EC. I feel like it's ECC. Error correction. So when gamma rays or whatever hit the RAM and twiddle the bits, the Tesla can fix that, but the RTX cannot. So yeah, not that important for deep learning. Which is pretty robust against site errors. Yeah, error code correction, thank you. Cool. Little tangent there into GPUs, but I'm glad I haven't looked into the latest stuff in a while, so I'm glad to be a little up to speed. Yeah, any other questions on BigBird? I'm not seeing anything in the chat, so I'm guessing we've tapped it out. Any other just general BERT questions while we're all here? See, I'm going to just add the note. We were able to what would you call that, reserve to launch. We were able to launch one of these instances at Panda. Yeah.
Well, I just have a question. So, did you happen to find why BigBird has more number of tokens given the same sentence compared to Bird? I think you mentioned that earlier.
Yes, let's see. Okay, so it's because it uses the SentencePiece tokenizer. And the reason I paused there is I'm trying to remember what's special about the SentencePiece tokenizer. I know that it was, they call it that because the original tokenizer was a word piece tokenizer, which was designed to like break up words in a way that would allow you to reconstitute words, whereas the SentencePiece tokenizer is designed to allow you to reconstitute the entire sentence. And I think that the difference there is mainly like preservation of white space. And if I remember right, like so Albert, when we studied Albert uses the SentencePiece tokenizer. So the ebook on Albert that Nick and I put together talks about it. It seemed like it was mainly targeted at some other languages where that white space information is actually really important. And so it's sort of a deficiency with the word piece tokenizer. But I think I don't think I got the impression from looking into it that it, you know, at least for English, let's say, that there was much difference between the two. But they do, you know, so they have different vocabularies for one thing. Yeah, I can summarize that.
So, I think if that is the case, then could we see, could we have better clarity if we perform the comparison rather than on question answering if we do it on translation?
Yeah, I don't think it. I don't think it had a huge impact. So so the number of samples, what would it be? Greater, yeah. Number of test samples greater than 512 was, I want to say it was 678 with BIRD and 680 with BigBird. So 2 samples got pushed over the edge, that 512 edge. Would be, yeah. I guess I'd be surprised, I guess, if the number of tokens actually varied that substantially. Yeah, I guess there's an interesting question there of like does SentencePiece result in longer sequences overall versus word piece? Because if it does, then that's a performance hit. But yeah, I guess we should also be careful. It's the vocabularies are different. So BigBird uses the Roberta vocabulary versus BIRD's original. And the 20 Newsgroups, I don't know how to factor this in, but the 20 Newsgroups has a lot of funky text because of the PC and Windows and like hardware discussion groups, which have lots of like, you know, acronyms and specs. So, maybe arguably like the vocabulary shouldn't work as well for 20 news groups because the 20 news groups text is crazy. Let's see. Yeah, any other?
Yeah. Okay.
Yeah. Just checking to see if anyone else had any, was weighing in on it at all, but is there any other key thoughts to capture there? Right. So SentencePiece was designed to allow you to reconstruct the full sentence, including white space, from the tokens. Whereas WordPiece doesn't guarantee you can do that. Yeah. So I think you can just summarize it as like SentencePiece captures white space. Cool. Yeah, that's a good question. Thank you. Uh-huh.
Yeah, I think if I recall, you mentioned that some of the sentences had about 40,000 tokens for BigBird, or if I'm mistaken somewhere.
Let's see, I didn't catch the first half of that. Were you saying the size, were you mentioning the size of the vocabulary?
Oh, no, actually, for the sentences, some of the sentences in 20 news group had about 40,000 tokens. Maybe I'm
Right.
something.
Yeah. I think the maximum is let's see, sequence length distribution, tokenize. Oh, there we go. Yeah. Minimum length was 2 tokens. Max is just under 50, median 126.
That's interesting.
Yeah.
That's per sentence.
Yeah, per sample, and I guess that's specifically for the training set.
Okay.
Yeah, and then I guess because of the scale of that, I didn't plot all the way out to 50,000. Just kind of showed the distribution within 512. And then again for, let's see, where would I have it in the notes at least? Yeah, and then this chart again, I truncated it at 4,000. I didn't go all the way out to 50 or whatever the maximum is for the test set. Yeah, let's see. So Ted Pearson pointed out that it's possible that just the additional context in the 20 news groups data set doesn't actually help. Yeah, which I think is a good point, quite possible. And yeah, it seems like I think that's been a big challenge here in creating a good example to demonstrate to showcase BigBird, is that really it'd be great to have a data set where whatever the key information is, it's further in the document. So I did kind of get the impression from the paper that, the two things they show it off on are they do document classification, but they also look at question answering. And it seemed like they had more rationale for why this would be useful for question answering, because there you can have you can have a long document and you could be looking for something very specific that only occurs in one spot in the document. So you need to be able to process the whole document in order to find it. Whereas it seems like if you're categorizing a document in some way, especially by topic, then there's a good chance that you can establish the topic just by looking at a nice chunk of the text and not actually the whole thing. Yeah. Right. Yeah, we all learned in grade school that your introduction should basically summarize your whole paper. So as long as you get that intro in there, you're probably good. There was a paper that we referenced in our original document classification tutorial, a year or more ago now. That did kind of play with that. They played with taking, instead of just truncating off the end, they tried it's like, well, what if you only take the end? Maybe the conclusion has the best stuff in it. And then I think they did actually get their best accuracy, by only slightly, by taking some of the beginning, some of the end, and then I forget how they took the middle exactly, whether it was random or just the exact middle. But yeah, some of the end, some of the beginning, some of the middle. So maybe, if you know somehow that your data has some kind of pattern like that, you could try to exploit it. Yeah, and I did see a couple of people mentioned that Transformers library now includes some vision stuff, which I came across that too. I think that's brand new. So Patrick, I linked to his Twitter profile and he announced that as well. So BigBird Pegasus. I'm not familiar with Pegasus, but it sounds like it has to do with document summarization. So that's there now. And then they also added vision. Image text similarity or zero-shot image classification. Huh. So I get this one. I get the image text similarity, but why state-of-the-art image classification? Why would that be in Transformers? Diet. Did we talk about that last week?
I think a few weeks ago we did touch on it a little bit.
Yeah.
Yeah, someone's asking about BERT or Transformers applied to vision, and the answer was we don't really know, but it seems like Huggingface is adding it. I wonder if they're branching into other data modes heavily, if they're just sort of introducing a few basic computer vision models just to have them.
There we go. Oh yeah, you brought it up, Vinay. Unless it was a different Vinay. VIT Vision Transformers segment. Yeah, okay. Right. And then Dieter. Right. Okay. So you can use the transformer architecture on images instead of a convolutional neural network. So I guess that'd be why it makes sense. For transformer-based computer vision models. Also, grab his tweet here. Is that going to work? No. Anyway. Cool. Okay. Any other questions or topics? Yeah, vision stuff. Vision is kind of where I started out before, like getting into Word to Vec and topic modeling, making a switch to NLP. Could be fun to go back there, and seems like maybe there's given that they're applying the transformer architecture to vision, maybe there's more justification there for us to dip into that. And then I've also been, I think another like significant thing that's kind of been missing from our content is like anything on text generation. You know, we've kind of focused on BERT, which does just the encoding side, but haven't explained decoders or looked at, you know, GPT-2 or any of that. So those are two big directions we could go in. Cool. Well, thank you guys. This is fun. I think I'm really glad. I've been wanting to look at BigBird for a long time. So hopefully the tutorial will be helpful. I think I'll try to include, like my understanding is that Longformer and BigBird are very similar. So we'll try to include in the tutorial a little bit on the differences there, so that partly so that we can call it, you know, a BigBird and Longformer tutorial, and like two birds with one stone there. So yeah, I think we'll wrap it up there, and I'll hopefully see you guys next week. Thanks.